So today, 11, 13, 17. What we're going to do is we're going to be graphing on a number line, quadratic inequalities. Okay? Graphing on a number line, quadratic inequalities. So, if I look at example 1, what I'm thinking is probably factor. Now we've got several ways to solve ones. We could use the quadratic formula. We could do completing the square. We could all these things that we've learned, these techniques. But what I want to do is probably factor. In order to factor, I probably need to set it equal to 0 because we're going to solve. So let's set equal to 0 first. Okay. Alright, so I'm going to go minus 3, so I can have an x squared minus 6x plus 5 is less than 0, okay? And of course, when I factor, it's a trinomial. Go 2 sets of parentheses, and I'm going to go x and x, and I know the multiples of 5, being 5 and 1, will make a 6. I use a negative 1 and a negative 5. When I multiply the two, they'll multiply to make a positive 5. When I add the two, I'll get a negative 6. Now, what I want to do is this. If I'm going to be on a number line, I'm going to set it equal to 0 to look for what I call border points. Border points. Really? I can't spell it all. Thanks. Really? There's no A? Border?
Well, there is, but it's a different kind of.
Oh my goodness. Good thing I'm a math teacher, not an English teacher. Doesn't make any sense, does it?
No, not really.
No. Okay, so then, let's go ahead and set it equal to 0 and solve. And if you do solve, you get x equals 1 and x equals 5, right? You get your little mini equations. I skipped that step, but I think everybody can. We've done this for 2 or 3 weeks now, so you know what I did, right? So then, my border points go on my number line. So let's go ahead and set up my number line, right? Okay, so I'm going to go ahead and put a 1 and a 5. I want to do my border points. In this case, I'm going to use open circles. Why am I going to use open circles instead of closed circles? There's no equal. Everybody agree with that? There's no equal right there. So it can be everything less than but not equal to. Okay, so now let's go back to our original problem. Okay, so let's go back to this one right here where it equals 0. And what I want to find are the ones. Now, here's the thing. We got 3 different regions. We really do. We got 3 regions. We got region 1, 2, and 3. Some of these answers are going to work. So we test. We test our regions. Okay, and when I test, I really like to use a calculator to do the work for me because not because I'm lazy, because calculator's not going to make a mistake, and I make mistakes, don't I? So I'm going to plug in. So I'm going to plug in values within my regions. Okay, so real quickly, region 1. Give me a number in region 1. Any number. 0. I agree. 0 is the easiest. You could use any number, but isn't 0 the easiest, right? So let's plug a 0 in. Okay, if I plug 0 into this one, okay, let's see. Let's check it out. Plug 0 into this one, so we'll go 0 squared minus 6 times 0 plus 5, and I get an answer of 5. Is 5 less than 0? Is 5 less than 0? No. So 0 is not true, so don't shade 0. Does that make sense? Now give me a number in this region.
3.
I'm going to put a big F for false, okay? Give me 3. I like 3. So plug 3 in. Let's see. I'm going to go, okay, 3 squared minus 6 times 3 plus 5. And I get an answer of negative 4. Is negative 4 less than 0?
Yes.
So everything in that region will work. So that means that if 3 works, so will 4, so will 2, because it's all within this region. So I'm going to shade that region there, okay? Everything in that region, because if 3 works, everything in that region will work, okay? Then let me test a value over here.
10.
Okay, 10. Why not? So plug it in. So I go, okay, what's 10 squared minus 6 times 10 plus 5, and I get 45. Is 45 less than 0? Is 45 less than 0? No, so don't shade it. So here's my region, and in set notation, I can say that 1 is less than x, which is less than 5, and there's my answer algebraically, okay? So that means all of these numbers plugged in, any of these numbers in this region, even 3.1, even 1.11, even 4.896, whatever, any number within this will give me a value less than 0, okay? Now, Leora said, hey, Mr. Davies is an example 2 exactly like example 1. Yes, but no. The only difference is the fact that it's greater than. So we're going to do it the same way. I did that on purpose so we have less work, okay? We just basically want to see what happens with the shading, okay? So again, I'm going to go minus 3, and I'll have an x minus 6x minus plus 5 is now greater than 0, right? We know if we factor and get our border points that equal to 0, we're doing the same thing, right? We're looking for our border points. Border, how's that? No A, huh? Border points. X minus 5, x minus 1. Obviously our border points are at 5 and 1. So it's the exact same problem we just did, correct? Exact same problem. So then if we go to our number line, and we just kind of did our number line, right? So if we did our 1 and our 5, open circle, right? And we already tested these. When we put in 0, we got a value greater than 0, didn't we? So we would shade this region here. That's the difference. In fact, I'll show you. We did the 0. Remember, we plugged in the 0, we got 5, right? There's the 0, we plugged in 5. Is 5 greater than 0? Heck yeah. So we want to shade that. Right. And then I plugged in my 3, and I got negative 4, which is negative 4 is not. It is not bigger than 0. Okay, so we don't shade there. And of course, we plugged in our 10. We got 45, which is indeed bigger than 0. So we want to shade that region. Okay. So that's all I wanted to show is that sometimes you shade the other region. Same problem, but with the inequality sign turned around, it's the other. Now, that's easy. How about set notation? We'll say 1 is greater than x, which is greater than 5, and there it is in set notation, okay? Now, example 3, why don't you guys put an equal sign on this? Just change it up. I forgot to put that when I was making up the worksheet the other day. I printed them off, and I was like, oh, dang, I forgot to change that one to equal. So we can just see the difference between open and dot, okay? So what are we going to do? Step 1, what do you think? Minus 6, we'll have x squared minus 4x minus 5 is greater than or equal to 0. Okay. We need our border points, we better factor, right? We need our border points, we better factor. And we should be getting good at factoring by now. We should. X minus 5, x plus 1, right? Set it equal to 0 because we're looking for our border points without an A. There you go. You are. Thanks. Getting it, right? I know I embarrassed Landon. It's a poor guy. He goes, Dad, that's not how you spell it. I'm so sorry, Landon. God, poor kid. Anyway, so we get x equals 5 and x equals negative 1, and those are our border points. So I'm going to do my number line, right? Does this seem pretty easy? If you can factor, this is easy, right? Okay, so then negative 1 and 5. Solid dot, because I changed it to an equal, right? Solid dot, right, okay. And then, what am I going to do? Well, okay, let's check. So let's pick any point, any value over here. Give me, oh no, over here.
Oh wait, that's not.
Any value over here.
-5.
All right, -5, -3. How about I would have gone -2, but I'll go -3. What the heck, right? So let's plug it in. So I'm going to plug it into this one here and see if it gives me a value greater than 0. So I'm going to go, okay, parentheses, I'm going to go -3 squared minus 4 times -3 minus 5 and get an answer of 16. Is 16 greater than 0? Is 16 greater than 0? Heck yeah! So it means I want to shade that region, okay? Okay, give me a value in here. 0. And you can see already if you put 0 in here, you just get -5. I don't need to use a calculator to show that, right? If I put 0, that just disappears. Is -5 greater than or equal to 0? Heck no. Don't shade that region. Give me a value over here.
57.3.
No. Give me something nice. How about 6? Okay, I'll use 7. Sure, I'll use 7. I'll use 7. Thank you, Megan. I'll use 7. I'm going to do, no. No, let's go with 7 squared minus 4 times 7 minus 5. And I get 16. Is 16 greater than 0? Yeah, so let's shade that region with true statement. Okay. Set notation. -1, less than x, greater than x, greater than, oops, that's a 5.
That's gonna have to be a quadratic.
I did that, didn't I? Okay, turn the page. Okay, now, example 2. Okay, there's 2 ways to do it. Example 4. We could complete the square, which is not a bad way to do it, or we can use the quadratic formula. I don't care. It won't factor. Okay, quadratic formula, how many vote for quadratic formula? How many vote for complete the square? Okay, quadratic formula it is. Does not matter to me, okay? Because I can do both, all right? So A is 1, B is 2, C is 7, right? All right. So let's go -b minus 2 plus or minus square root of b squared, which is, let's see, b squared is 2 squared minus 4 times a times c all over 2 times a, right? Quadratic formula, which I should probably put up on the board, shouldn't I? And leave it up there, right? I'm going to put it up here. Actually, I should put it up over there. I'm going to put it up over there so it always stays. Let's just put it up here so you guys always have it, right? Let's put up here -b plus minus square root b squared minus 4ac all over 2a. Hey, you want to hear something good from me? Not that you guys care because I tell stories all the time, but they will not do testing in my room.
Really?
Which is great because I never have to get my room. You know why? Because I got formulas all over the place, right? So
That is true.
I'm like, yeah, okay. So we're going to have a -2 plus or minus the square root of b squared, which is going to be a...
Because we did that one test after first.
I know. And then later on they found I had formulas in here. I'm like, well, I told you. -2 plus or minus square root of -24 over 2. What's going on here?
2 over 2.
Yeah, well, I got a problem, don't I? This is an imaginary number, right? That's an imaginary number, right?
Yeah.
So no matter what number you plug in here,
Yeah.
it'll never be less than 0, right? It's impossible, right? So this has no solution. How about this one? It's the exact same problem, isn't it? Well, no, just give me any number off the top of your head. I don't care. Give me any number.
2,365,400.
I gotta put that in the calculator, okay? How about give me a simple number? I gotta put in the. How about 2? So we're gonna plug 2 in, okay? 2 squared plus 2 times 2 plus 7. Give me answers 15. Okay? Is 15 greater than 0?
That does work.
Everything works. Everything and anything. Try negative. Let's try a negative number. Give me a negative number.
-15.
-15. I like that. Okay, let's go. -15 squared plus 2 times -15 plus 7. It'll always work. This one will never work because it's less than 0. This one will always work. Now, you want to see something real quick? So this has all answers. So real quick, because I want you guys to see this. If I were to graph this parabola, it would look something like this. Okay? If I were to graph this parabola, it would look something like this. Okay? Just, go along with me, okay? So, when is this parabola below the x-axis? Never. When is this parabola above the x-axis? Yeah, so sometimes we got to think a little bit, huh? Okay. All right. Example 6. We're almost done, okay? All right. Example 6. We got a torus equation, okay? Let's finish this up, huh? Okay. We are almost done, right? I'm going to get to this one. So we do exactly the same one. Almost done. I know, it is a tourist problem in a tourist town. Isn't that crazy? You know what's that all about, right? Okay. Yeah, I know, that's crazy, huh? So, models profits, okay? Write this as a quadratic model, okay? So we want profits. We want profits to be greater than 0. Would you agree with that? So let's go negative 25x squared plus 100x minus 3,000 greater than 0. Greater than 0. Not even equal to, because if it equals 0, have you made a profit if it equals 0?
No.
No, you haven't made a profit. You got to make 1 penny to make a profit, right? If it equals 0, it's just you go home with nothing in your pockets. Sad. But then you don't have to pay anything either. It's still sad. Okay. So, how many people are needed for a profit of at least 5,000? Okay, so if we need a profit of at least 5,000, let's change this to negative 25x squared plus 100x minus 3,000. We better have at least 5,000. Okay. How are we going to solve this problem? How are we going to solve this problem? What do you think? How are we going to solve this problem?
Make it equal to 0.
Okay, I agree. All right. Minus 5,000 minus 5,000. Negative 25x squared plus 100x minus 8,000 greater than or equal to 0. Looks like maybe the quadratic formula, but I want to make it a little bit easier. Because I've been doing math forever, I see something that's going to help me. What do you see? Yes, thank you, Leora. Yeah. Do you guys, I don't like these big numbers. That's an ugly number. Hey, you're here. That's a big number, that's a big number. I guess I just saw you. I'm going to divide by, if I'm going to divide by negative 25 first, right, then I'm going to get a positive x squared minus 4x plus, I don't know, what's 8,000? Clear, 8,000 divided by 25. I get 320, right? Greater than or equal to 0. Will that factor?
That,
Did I make a mistake?
You divide, bro.
What? Oh. That factors. We don't even have to use the quadratic formula. Wow, sweet. Yes.
Isn't the sign flip?
Yes, if you're dividing.
Yes, it does. Thank you very much. Thanks, Simon. You're totally right. X, and we got a 16 and 20. We got a minus 20 and a positive 16, right? We get x equals 20 or x equals negative 16, but I'm going to throw away the negative 16 because you can't have negative people. You okay with that? Because the whole x represents how many people, tourists, so we get rid of the negative tourists, which wouldn't we all like to get rid of the negative tourists?
Yes.
And a positive 16.
No, I'd rather get negative tourists than get rid of them.
Oh.
But when the class is
That won't work.
What is a plus 320?
It's a plus 320, not a minus 320.
Lachlan,
That won't work.
native tourists doesn't mean you have less tourists. It just means if they touch, they cancel out.
All right, let me come back to that one, okay? Because then I don't want to use the quadratic formula. We're going to stop there. I'll come back. I'll figure that one out. Okay, so I'm going to look at that because I thought that worked out. I'll have to check it out.
Well, it doesn't work. I mean, it would work, but it doesn't.
No, you're right, and the book does the quadratic formula. They do the quadratic formula. They get. I don't know. I like this one better.
If it was...
They do the quadratic formula, okay? Yeah. Stop.
What's the
Stop.
square root of 1,280?
You did not